which we'll discuss it earlier. Okay, so now I'm sharing the screen. So is it visible to you? Brahmateja, screen is visible?
Yes, sir.
Okay, it takes time. When I asking, when at the time of I am asking that the share is screen is not visible to you, it takes some time.
No, sir.
Immediately it is visible.
Yes, sir. Visible, sir.
Okay, voice is okay.
Okay, sir. Clear, sir.
Okay, right. So now we'll refine the last class what we discussed. Factor of safety, right? So why we are considering the factor of safety factor? Because so many complexities in the size and shape of the component, at the same time uncertainties in the load application. Because of complexities and uncertainties, the factor of safety is considered while in working. Due to the consideration of factor of safety, so we are not working at the maximum strength of the component, ultimate strength or maximum strength of the material. We are working below the below the acceptable strength of the component. Since under safe working conditions, if any abrupt load or abrupt loads are acting on the component, though the abrupt loads are acting on the component is safe while we are working. That is the reason why we are taking the factor of safety. Okay, so therefore this factor of safety is defined actual strength by required strength. Required strength is nothing but working strength. Already we discussed earlier, almost all 1 hour. Required strength is nothing but working strength. While you are working, what is the strength? The actual strength is maximum strength of the component that can withstand. Therefore, actual is always more than the required strength, working strength. So, factor of safety is always more than one or more than one. Right? Under extreme conditions, equal. Therefore, this strength we can express in terms of stress, maximum stress by working stress. For ductile material, this maximum stress is considered as a yield stress by working stress for ductile material. In case of brittle material, we cannot identify the yield stress. We can take ultimate stress by working stress, right? Therefore, factor of safety denoted by N equal to actual strength by required strength, which is equal to maximum stress by working stress, equal to yield stress by working stress for ductile materials, yield stress by working, uh, ma- uh, maximum ultimate stress by working stress for brittle materials, right? And the factor of safety is always more than one. Too much high factor of safety takes the large amount of material consumption, cost is high. And too much low factor of safety is considered, so risk, high risk. We are considering the high risk. Therefore, moderate, appropriate factor of safety must consider. What amount you can consider, whether you can consider the one or whether you can consider 10 or more. So based on the real conditions, right? You have some idea about the real conditions, but you cannot exactly predict the uncertainties. But we have some idea. Based on some idea, we can take moderate value of factor of safety. Okay, this we can discuss in the last class. Now, and similarly, margin of safety in aircraft design, margin of safety is also considered. This margin of safety is equal to factor of safety minus 1. Factor of safety minus 1. And we are expressing this margin of safety in terms of percentages also. Percentages also. Right? So this we discussed in the last class. right? Is it clear? So up to this last class we discussed. So what is factor of safety, and what is margin of safety, and what is the importance of factor of safety, right? So explain the importance of factor of safety, or what is the importance of factor of safety. Define the factor of safety, right? So these are all parameters to define the factor of safety. Okay. So only 11 members are joined. What about the other one? Already I shared the link also, but still only 11 members. So if this it is difficult to maintain these timings. So with the request of you are all is the students who can change these timings. Okay, please maintain the timings and join within time.
సార్ మార్జిన్ ఆఫ్ సేఫ్టీ చెప్పలేదు అనుకుంటా సార్.
చెప్పాను సార్, లాస్ట్ క్లాస్ డిస్కస్ చేశాను. మార్జిన్ ఆఫ్ సేఫ్టీ ఈజ్ ఈక్వల్ టు ఫ్యాక్టర్ ఆఫ్ సేఫ్టీ -1 అని డిస్కస్ చేసాం. సో ఎనీహౌ ఇట్ ఈస్ నథింగ్ బట్ సింప్లీ డెఫినేషన్. ఓకే, it is so it is nothing but a simple one point definition which is taking as a factor of safety -1. Okay, so major importance we are giving the only factor of safety. So margin of safety is a simple definition. Okay, so now even 11 members only, but it is difficult to each and every time to stay and stop. Let us continue the factor of safety. Factors affecting the factor of safety, right? So what are the factor influence the factor of safety? So factor of safety is nothing but maximum stress by working stress. It may be considered either 1 or some value to 10. All right, it is ranging more than 1. It is considered more than 1, right? So therefore, while considering the factor of safety, what amount you can consider, or what is the necessity of to take the factor of safety, already we discussed. So that necessity, which factors are influencing to take the factor of safety, okay, that we'll see now. So if you have any doubt at any point of time, any person you can raise, or today class, that is you can give the responsibility. Brahmateja is the responsible person to give the answer. Okay.
ఓకే
Okay, right. So the determination of factor of safety must be taken into account. Much matters of the following: probability of accidental overloading of the structure by loads. So already we discussed the load is not constant. When you are riding a cycle, we are designing only the load whenever the person sitting on the cycle. That is the weight of the load acting on the cycle, and in addition that weight of the cycle also, weight of the person, weight of the cycle. Suppose if you are working on any machine, so the predetermined force already you are calculated as a mechanical point of view, that is the load acting, right? But certain cases the load is varying suddenly. So due to the increasing in cross section, or due to the dynamic considerations, okay, so one point of time, if this load is not continuous throughout this one, only fraction of time, only fraction of time, so this load is maximum suddenly increases. So actually you are designing the that the maximum strength of the component is 20 kilonewtons. You are designing the component size also for 20 kilonewtons. At one point of time, this load is the load acting on the component is not continuously on. At one point of time, a particular fraction of time, the load is acting 25 or 30 kilonewtons. You are designing only 20 kilonewtons, but the load is 30 kilonewtons. What happened? So therefore, suddenly the component is break, right? So this you cannot predict ever. That is therefore type of load. So the type of load. So we are we are designing under ideal conditions. Ideal conditions, that is laboratory conditions. In the laboratory conditions, we are applying the static load only. We are applying the static load only. So take the component and apply the static load, apply the load, and constant prismatic. Take the prismatic bar, right? So another apply the constant load and study the variation of the material property. Material property. So if that studied, then you can get the upper yield point is like this, right? But in actual conditions, we are not always apply the static load. Certain case dynamic load also. Dynamic load is also acting. So since dynamic load, so the load is continuously varying. Yes.
Okay, sir.
Okay, na? Some are disturbance. Okay. So if the dynamic load is acting, it is continuously varying. So maximum to minimum, or the load is a variable load, the dynamic load, right? So due to that, the yield strength, the maximum stress induced in the component may be suddenly increased with less load. Okay. So for that, you can take the consider the factor of safety. Since the already sigma y maximum stress values are calculated under the uniaxial condition. Uniaxial condition, prismatic bar, constant load, right? So constantly we are using, that is load is constant. So though it is small increasing slowly, but we are increasing constantly, not a irregular manner, right? So under that condition, we are finding the yield point stress or ultimate stress for that one. But here the actual condition, the load may be not be a static, and even it is a dynamic load also. Dynamic mode is suddenly applied load, impact load. Yeah, these are all comes under dynamic loads, right? Due to that, high stress is induced. Due to this high stress, suppose if it is increase the yield stress or touches the yield stress, then the component is fail. So under safety condition, you always working below than this. Therefore, take the considerable factor of safety. That is one of the factors type of load, whether it is static load or dynamic load. Next, whether the loads are applied once or repeated. Whether the loads are applied once or repeated, right? If the load is so constantly increasing load we are applying, right? So that is axial load which is acting on the member is slowly increased, right? And then remove the load, and again can I apply the repeatedly apply the load, remove the load, apply the load. Then what happened? So fatigue occurs, right? Fatigue occurs. Like if you see this one, we can bend the wire, bend the wire in one direction first, then leave the load, and then again apply the load and bend this direction, and bend this direction, and bend this direction. What happens suddenly? At one point of time, the wire is break into 2 points, right? So that is repeatedly. So we are applying the load repeatedly. So therefore, so if we apply the load repeatedly, so then you can consider the factor of safety. So then the stress induced, the ability of the material is slowly reduced, right? So therefore, if it is one time to another time it is reduced, you can consider the factor of safety, right? So next, how accurate loads are known. How accurately the loads are known values. So therefore, if you are known the accurate values of the uh, loads, means we don't know the accurate values of the loads. Exact load quantity, what is acting on the quantity is we are not exactly predict. Therefore, whenever the load we are not exactly, so we are designing, but so little bit of this load, 20 kilonewtons load is acting, but it is varying from 20 kilonewtons to little bit above and below. So therefore, the accurate value of load acting on this one, so we cannot one. Even though we are designing and applying the 20 kilonewtons load, due to the friction and due to the some height we are dropping, and due to the wear and tear, so some extra load is acting. So therefore, we are not exactly accurately what load acting on the component, so we cannot predict it. So that is another factor which influencing the considering a factor of safety, right? So possibility for fatigue failure, possibility for fatigue failure. So we already discussed in the that is a fatigue failure, that is a repeated reverse stresses. So repeated reverse stresses. So one is bend like this, another one is like with this. So then it is a fail is occurs. Then in that cases, so you can apply the you can consider the factor of safety. The more factor of safety you can consider. Okay. And next one, inaccuracies in construction. Inaccuracies in construction. So suppose uh, two two rods are required to join, right? And the two rods are required to join. Then so if you join the using welding or riveting, whatever the method you can use to join. So due to the joining methods, you can say suppose 3 or 4 persons you can joining like this. So all 3 and 4 persons cannot be join the equipment in the same manner, right? So you cannot able to joining all this one the same manner. So if you ideal cases, if you this structure can be withstand certain load, then one person build the experienced person can join the two components with a high strength, and then somewhat low experience strength cannot able to reach that much of strength. So if you design, okay, yes, I can design, it can withstand the 30 kilometers, so you can apply 30 kilometers of load due to the other person inaccuracy, so the component is failed, right? So the system can be sustained under any circumstances. Therefore, you must take that consideration. You cannot predict all 5 or 6%. A group of persons work at for construction. All group of persons, all number of persons cannot build or construct the structure in the same manner. It is varying from person to person, right? Due to that, to avoid that inaccuracies, so you can also consider the factor of safety. Next, variability in the quality of workmanship. Variability in the quality of workmanship. Skilled person, unskilled person. Skilled person, unskilled person. Right? Suppose if you make the one component of 20 mm diameter, so skilled persons can make the component of diameter 20 mm. So maybe exactly 20 mm, maybe exactly 20 mm or 20.001 mm. So this is the one component which you can apply the load, right? So the diameter, cross section diameter is taking as a 20 mm. So you are giving the rod and make the 20 mm rod. So that 20 mm rod, I can apply the load, some load, a 50 kilonewtons load. So one person, skilled person, make the this component with 20.001 mm accuracy, right? Almost all the bar, entire bar diameter 20 or 20.001 mm accuracy. Suppose if you take the unskilled person, so the same component is made with 20.01, and some portion is 20 and some portion is 19.99, or some portion 19.98, right? So throughout the length of the length, throughout the entire length of the one, this surface irregularities, this irregularities like this, the surface irregularities like this, the surface irregularities like this, the micro level you can get, right? The skilled person having the this irregularities very less, and unskilled person having the micro level this irregularities more, right? So whenever this variation in this cross section, load is same load, though we are considering the same load, at one point of time the component is high strength, at one point of cross section it is a low strength, right? So due to the less cross section, so therefore workmanship, the quality of workmanship, skill, experienced person, unskilled and a low experienced person. So you can say skilled person, unskilled person. Skilled person can make the component with a more sizes, precise sizes. Therefore, it will withstand more strength. And unskilled person, maybe it can be varying with less like this different sizes. They have less strength. So that is also affect the factor of safety. So we cannot stop the skilled and unskilled person separately. The entire mass production all components considered into one as a assembling one unit to assemble the final structure. That structure is used for applying the different applications. So that application point of view, what is the load we are designing, right? So therefore, considering all these factors, the what amount of load is acting on the structure, that we can decide. That load must be less than the maximum load, the yield stress load. Okay, you must work below the yield stress load, since these are the possibilities of factors which we can express, right? And the next one is the material property, variation of material properties. Next is the variation of material properties. Material properties means what is the material we are assuming initially? Material is homogeneous. Material is homogeneous material, right? The material is same throughout the throughout the cross section, throughout the length. It is a homogeneous material. Can we say it is a completely 100% homogeneous? Since we are taking the raw material from elsewhere, right? So we are not physically, we are not making the component to the homogeneous. So if you go to the market, so give the iron rod, they can give the iron rod, right? So and other person the aluminum rod, like this. Even it is a pure 100% iron rod, pure 100% aluminum rod, right? Or pure 100% gold. You can just take the example of gold, right? Pure 100% gold. We are making some a fraction of one is the adding with silver, right? Similarly, this for getting the shape and size or mixing with milk, we can take the milk, right? So can you say it is a pure 100% of milk without any mixing of water, right? So these are all variations. So therefore, so due to the variation of properties of the material, actually we are assuming and designing, we are finding the yield stress and ultimate stress under homogeneous material, right? So always stress strain curve is involving here. This is the curve obtained for homogeneous materials. But if the material is not homogeneous, means it is homogeneous, but a little bit fraction of 0.1, 1% or 2% is mixing with other materials. Since by purification, purification of the material, a fraction, so the 0.1 or 0.01, like the 1% or 2% of other materials also mixed with the homogeneous material, which cannot be avoided. Due to that, also the strength of the material is varying, right? Remember, this is the we are finding the ultimate yield point strength for pure homogeneous materials, right? So we cannot authentic, or we cannot say the component is made with purely homogeneous material. It may be a mix with 1% or 2% other material. Then the component strength is vary. So how can you compensate it? So you think that this component is homogeneous material having a 30 kilonewtons of capacity strength, or 30 kilonewtons per mm square is the yield stress. Then but due to the impurities, due to the mixing with other materials, its strength is only 29 kilonewtons per mm square, right? But you are giving that material what you can take as the iron or steel having this 30 kilonewtons per newton per mm square, but only it is 29 due to the impurities existing in the material. If you design like this, it is having only this one. Whenever 29.1 newtons per mm square, kilonewton per mm square load is acting, so then immediately the component is failed. But according to your design, 30 kilonewtons is the safe stress, ultimate stress. 30 kilonewtons per mm square is the yield stress. Only stress is 29.1 kilonewton per 29.1 kilonewton per mm square. Why the component is failed? So due to this one, therefore, to save conditions, we can take the factor of safety, which the variation of properties of material is also influencing the material strength. Next one, environmental effects. Next is the environmental effects. So under laboratory conditions, we are finding the SN curve. We are finding the SN curve, room temperature, like room temperature, right? So say room temperature is some 25 centigrade or 30 centigrade, like this. Suppose always the temperature is same while working. Suppose if you take in the winter session, the temperature is less, and in summer area, summer sessions, the temperature is more. Like the temperature is varying from day to day, right? And other environmental conditions, so humidity, like all these conditions also consider, which affect the strength of the material. That also considered. Next one, the accuracy of method of analysis. Accuracy of method of analysis, right? Which method we are following? So Newton per mm square, we are while calculating some, suppose 39.01, right? So suppose if you take 39, so this much of what is this accuracy? How accuracy can consider, right? So therefore, different methods we are using. One method is somewhat nearer, very closer to the results, and some methods is maybe somewhat away from the one. So therefore, which there were accuracy of method of analysis. So you are following the different methods. That accuracy, how much it is, also is influencing the strength one. Yes, I can follow this method. That strength is obtained as only 28 kilonewtons per the yield strength is obtained as 28 kilonewton per meter square, but your actual strength is equal to 30 kilonewton per mm square. Therefore, the component is safe. Okay, but another method, it can be obtained as some same value. It may be 30.1, 30.1, 30.2, like this. Then the component is fail, right? So to avoid the failure of the component and it performs its function successfully, fruitfully, right? So then for that we can take the factor of safety. So these are all the factors which we cannot predict initially, right? So these factors are cannot predict initially. Even we are somewhat study also, we cannot identify. So whether it is some cases, whether the load is a static load or dynamic load, we can particular applications we can study it. And load is applied repeated or not repeated, maybe we can identify it. But construction inaccuracies, we cannot avoid it. And quality of workmanship, you cannot avoid it. Properties of materials, though you cannot avoid it, right? So determination of due to corrosion. So the corrosion, at what level the corrosion is existing. If you put the material into the atmosphere, expose into atmosphere conditions, maybe the corrosion is existing. Or if you safe conditions, after some time the corrosion may be existing, right? So environmental conditions, we cannot avoid it. So therefore, so many factors we cannot avoid it. Like so now the corona, we can live with corona in a daily. We cannot avoid it. We can live with corona. So we cannot avoid it. These are all difficulties. We can engage all this one. We can entertain all this one, but we can entertain all this one, and at the same time work with safety. Work with safety. So for that, what you can take? So take the factor of safety. Take the factor of safety. So therefore, see that in all conditions, working stress, N is equal to working stress should not exceed the sigma y, right? Yield stress, this is the working stress. So working stress should not exceed the uh, ultimate stress. That is always the working stress less than the yield stress. For that, we can take considerable amount of factor of safety. The considerable amount of factor of safety can consider, so that so the working stress is always less than the yield stress or maximum stress. So under the safe conditions, therefore working stress is equal to sigma y by uh, factor of safety, FOS, factor of